All right, so welcome back to all the NEET aspirants. Welcome back to your only channel, NEET Success Simplified. And I am Dr. Shankar, your physics educator. So, guys, in this video, we are going to discuss some more previous year questions of the physics from the chapter of units and measurement. Okay, so this is the part 2 of previous year questions of NEET examination for NEET 2024 physics. So as I say always, solving previous year question is very important. So I am here with you again to solve some more previous year questions so that you can have more understanding of this particular unit. Okay. Okay, so let's start with the first question for today's session. So if the dimensions of a physical quantity are given by m to the power a, n to the power b, t to the power c, then the physical quantity will be. So how can we solve this question? So we have here four options. So here we have only one option, that we go by the option and check one by one. Now, velocity, if a is equal to 1, so velocity, this can't be the answer, because velocity is the displacement per unit time, change in displacement upon change in time, so it has nothing to do with the mass, obviously. Now acceleration is also change in velocity upon change in time, so that means a can't be 1 because it has nothing to do with the mass again. Now force, for force, A is equal to 0. So this can't be the answer, because force, we memorize this, that the dimension is mlt minus 2. Now you need not to see the D option, because it is going to be the C. When we have four options only and the first three are incorrect, we can straight away write the D option for saving the time. But if you want to check the units of pressure, so what is pressure? Pressure is a force upon area. So we know the force, unit of the force, the dimension of the force is mlt minus 2 upon L square, So what is the dimension? So ml minus 1 t minus 2. Okay, so the answer would be the pressure. I hope it is fine to everyone. Right, now let's move to the next question. Okay, so here we have the next question. Very interesting question. Now let's try this question. I'm very sure we can do it. I'm very sure we can do it. Please try it. Please try it. Let's try this one. So it says the velocity of a particle, velocity v of a particle at time t is given by v is equal to at plus b upon t plus c, where a, b, c are constant. The dimension of a, b, c are. Now let's do it quite quickly. Now please understand this. Please understand this and tell me that, see what we have seen. So we have seen that two physical quantities can only be added when they have the same dimension. Okay. So now t having the dimension of t is having the dimension of t. Okay, this is having the dimension of t. This is having the dimension of t, obviously. So what would be the dimension of c? So the dimension of c should be t. Now c, without doing anything, within 30 seconds you can solve this question and can straight away answer that the answer is D. The answer is D. Right? Right. But for sake of solving, if you want to find dimensions of each of this A, B, and C, so C is already found. Now what we know from the principle of dimensional homogeneity that for a equation, for any equation, the dimension of the terms on the left hand side shall be equal to the dimension of the terms on the right hand side. So on the left hand side we have V. Okay, so what is the dimension of V? Dimension of V is Lt minus 1, because it is the velocity. So we can say the dimension of At is equal to the dimension of V. The dimension of V. So dimension of At. So what is the dimension of T? What is the dimension of this T? What is the dimension of this T? The dimension of this T is capital T. And what is the dimension of this V? The dimension of V is Lt minus 1. So from here we can write the dimension of A is Lt minus 2. LT minus 2. So again, we are going to get the same thing only. Now, if I write for B upon T plus C, so what we can say? We can say the dimension of B upon T plus C is equal to the dimension of V, is equal to the dimension of V. So we can write the dimension of B upon T plus C equal to LT minus 1. Now C has the dimension of T. So in the denominator we have T. In the denominator we have T. So this is LT minus 1. So what is going to be the dimension of B? What is going to be the dimension of B? So it is going to be L, and T minus 1, T is going to become L. Okay, so the dimension of B is L. So now in the examination, in the competitive examination, are you going to solve for each of them? Are you going to solve for each of them? No, sir, certainly not. Because right away, by understanding the unit of C, by knowing the unit of C, we can right away choose the correct option. And ultimate game is that we must select the correct option. Okay, whether you have solved this is not a conventional paper. So whether you have solved any question completely or not, that doesn't matter. Okay, you must come down, you must bottom down to the right option. And if you can do that, definitely you are going to get score of 4 out of it. Now, moving to the next question. So, guys, I am hoping that you are solving. Oh, it is getting the rotation. Oh my god. Yeah. Okay. So now I know, guys, that you are solving these questions before I attempt them. Okay. So that is necessary. Do solve this question before I do them. Okay. Please go for them. Please go for them. I am very sure we can do it. So now these questions, so I hope you, after watching all the sessions we had, you must be finding these questions very easy, very simple. So it says the dimension of universal gravitational constant is, so what is the dimension of universal gravitational constant? So now for that, we must know the formula of universal gravitational constant. So what is the formula for universal gravitational constant? So sir, we know that for the first question we can say F is equal to G m1 m2 upon R square. So if you remember, guys, we have solved this question. We have solved this question before also during our sessions. Okay, so we have come up with, when I was telling you that what is the okay, so just give me a moment. So I'll because I can see that this question is not completely visible, so I'll just do one thing. I'll just do it, okay, like this. Okay, now this is better. You can now completely see this question. Okay, see these questions. So I was saying that in during our sessions also we have seen this. During our sessions also we have seen this, that I told you that some constants are not dimensionless, and there we have sorted out. We have seen we have found the dimension of this gravitational constant. Now again, in the form of questions, we have to do it. Okay, so we know that F is equal to G m1 m2 upon R square. Okay, so F is the force of attraction between the two masses. M1 and M2 are the masses, and R is the distance between that masses. Okay, so from here I can write G is equal to F R square upon M1 M2. So from here what we can do, G is equal to, so MLT minus 2. Okay, what is the unit for F? MLT minus 2. And what is the unit of R square? So what is the dimension of R square? It is L square. And M1 dimension is M, M2 dimension is M. So it is going to be M square. Now let's see if we bottom down to some options. So right away we can write B option. See, it is always and always, so don't you ever do the question in the examination without seeing the option. Sometimes you don't have to. This is how you save the time in the examination, no? Because so many questions are there. Okay, you have to be careful about the time frame also. Okay, like this, in this question, without doing all the calculations. So one student, what he can do, he can go and calculate each and everything one by one. Okay, rather what you can do, you can try to see from whatever you have done till some point of time that whether you have reached the correct option or not. Now, in this case, I can clearly see that we are getting m to the power minus 1. We are getting m to the power minus 1. So, what is going to be the correct option? The correct option is going to be the B option. I hope it is fine to everyone. Okay. Okay. Now, now let's go for the next question. Let's go for the next question. So, what is the next question? What is the next question? So, sir, it says the dimension of Planck constants are same as. Okay. So again, we have sorted out the dimension of Planck's constant. If you remember, did we or didn't we? Did we or didn't we? So we have taken the dimension of the Planck constant. We have seen the dimension of the Planck constant. Also, it is also a constant which has dimension. So not all the constants are dimensionless. Remember that. Now, please understand this. Let's solve this. So, how? So, first of all, we must know the formula. So, we are not knowing the formula right now. That's okay. During your journey of physics, you are going to come up. You are going to see these formulas in the due course. Okay. So, what is the Planck constant? So, E is equal to HF. Okay. So, we have also seen in the previous sessions also. So, E is the energy, H is the Planck constant, and F is the frequency. What is it? It is the Planck's constant. It is the Planck constant, and this is your frequency. And this is your frequency. This is your energy. Okay, so what does the question says? So the question says that what is the dimension of Planck constant? Planck constant. Okay, so first of all, it can't be energy, right? It can't be energy. Why, sir, it can't be energy? Why, sir, it can't be energy? Sir, it can't be energy, because Planck constant itself is energy upon frequency. Okay, so it can't be energy. Now, let's sort out to some dimensions. So energy. So H I can write at energy per unit frequency. And what is frequency? Frequency is 1 upon time. Okay, 1 upon time, right? 1 upon time in a way, dimensionally. Okay, or the dimension is p minus 1. So it can't be power also, because power is energy per unit time. Energy per unit time, and Planck constant is energy per unit energy per unit frequency. So it can't be your option. Okay. Now we are left with momentum and angular momentum. Momentum and angular momentum. So still we have to find the dimension of it. So let's find the dimension. So the dimension of H, the dimension of H is going to be ml. So what is the dimension of E? It is ml2, t minus 2, it is t minus 1. So we are getting ml2 t minus 1, ml2 t minus 1. Okay, ml2 t minus 1. So basically now see what I'm trying to do here. I'm trying to tell you how quickly we can turn up to the right option, how we can quickly come up with the right option. So for m we have a kg, for l square we can have a meter, and for t we have second minus 1. Okay. Okay, now let's see. So if I say angular momentum is I omega. So right away I can answer it, because I is kg meter square. Kg meter square, omega is radian per second. So what is the unit of angular momentum? The unit of angular momentum is kg. The unit of angular momentum is kg meter square per second. So that it must be the right answer. Okay. So the dimension of the Planck constant are same as that of the angular momentum. I hope it is fine to everyone. Okay. Okay. Now let's move to the third question. Let's move to the third question. So let's read the question. Let's read the question. Very, very simple question. I hope you are solving these questions. So till now, this is the how many questions we have done till now? 1, 2, 3, 4. So this is the fifth question. So which of the following groups have quantities that do not have the same dimensions? Pressure, stress have the same dimension. Okay. Both are force upon area. Velocity, speed are the same dimension. Displacement per unit time, distance per unit time. Force and impulse. So force and impulse, what is going to be your answer? Force and impulse. Because impulse itself, what is impulse? So impulse is the force in some change of time. Force in some change of time. So F into delta T. Okay. So which of the following groups of quantities do not have the same dimension? So force and impulse don't have the same dimension. They don't have the same dimension. Okay. 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 Now, let's move to the next question. So we have the dimensional formula for magnetic flux. What is the dimension formula for magnetic flux? So let me take it to a little bit faster. So what was the dimension of this magnetic flux? So what is magnetic flux? Magnetic flux is equal to, what is the dimension of magnetic flux? So magnetic flux. Okay, so I hope you are solving this. So the magnetic flux is equal to magnetic field. Sir, we don't know this formula. Don't worry. Don't worry if you don't do it now. Don't worry. So magnetic field into area. Magnetic flux is equal to magnetic field into the area. So if you have done the magnetism, you must know this formula. If you haven't, don't worry about it. We are going to reach it very soon. Okay. Okay. So what is the dimension of this magnetic field? So, sir, we did it previously. So it was mt minus 2, mt minus 2, a minus 1. So I'm directly using the dimension of it, because see, there are something that I have to tell you. But see, if I start telling you all this thing, you won't get the context. So I'm directly using the dimension. Okay, so it is mt minus 2, a minus 1, and the dimension of area is L square. So what is going to be the dimension here? So it is going to be ml square, and this is t minus 2. So we are going to have A option. We are going to have the A option. Okay. 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 So, so I hope it is fine to everyone. Yeah. Okay. Okay. Now, now coming to the next question. Okay, let's have one more. Okay, I hope you are enjoying this session. Now let's try this one. Let's try this one. Let's see how we can solve this. Let's try these. Very interesting questions, though. Okay, so we can have them read. And I'm hoping again that you are trying these questions before I am solving them. Right? So how can we solve these questions? So let's move to the first question. How many questions have happened till now? So we have, okay, 1, 2, 3, 4, 5, 6, and this is 5, 6. Yeah. So we have done 6 questions till now. Then moving to the 7th question for the day. So the force F on a sphere of radius A is moving in a medium with a velocity v is given by F is equal to 6 pi eta A v, the dimension of eta r. So let's write the formula. So F is equal to 6 pi eta A into velocity. Okay, so we want to find the dimension of eta. So we know by the principle of dimensional homogeneity that the dimensions of the terms on the left hand side must be equal to the dimensions of the term on the right hand side. So what is the dimension of F? It is ml t minus 2. What is the dimension of the 6 pi? It has no dimension. We need to find the dimension of eta. So let it be like this. And what is A? So here don't confuse A with the area. Okay, A, read the question properly. It is the radius of a sphere. So what is the unit to, what is the dimension to A? So it is L. And what is the dimension to V? So the dimension of V is going to be LT minus 1, because V is velocity. V is velocity. Now let's check the options if we are merging down. So each we have M, okay, very well. L minus 1, okay, M, L minus 1 and T. So basically, this is the answer. You don't need to solve it completely now. Okay, in the examination. In the examination, you need not to. You need not to solve it completely. You can right away give this answer. So how come? Let's check. So we have the dimension of eta m. This L cancel out, t to the power minus 2. That means we are left with t minus 1. And here L goes there. L goes there. So it will become m L minus 1, t minus 1. So this is the dimension of eta. Now, this equation is given by P plus A upon V square is equal to B theta by V, where P is the pressure, V is the volume, and theta is the absolute temperature. Okay, theta is the absolute temperature. Okay, so this is you are going to see in the Thermal van der Waals equation. So this equation, in this we are needing to find A and B. Very interesting question, guys. Please attempt it before I do. This is going to clear a lot of concepts in your mind. Please try it. Please try it. What does this question say? So it says an equation is given as P plus A upon V square is equal to B theta by V. Okay. Okay. Very, very interesting question. Now, sir, how we can do it? Now, please understand this. Please understand this. So we have, so let me write this equation here. So we have question P upon, so nothing is in upon, P plus, what is the equation? A upon V square is equal to B theta by V. B theta by V. Now, please understand this. Please understand this. What is to understand here, sir? Now, see, one way you can do, sir, the dimension of these. So, if I say the dimension of A upon V square shall be equal to the dimension of P. Do you agree to it or not? Why this is so, sir? Because two dimensions, two physical quantities can only be added if they have the same dimensions, right? If they have the same dimensions, so clearly the dimension of A upon V square is equal to the dimension of the pressure, that is P. Okay, so can I write like this? The dimension of A by V square. So V is volume. That means we are having L to the power 6, because for a volume we have L cube. For a volume we have L cube, because V is the volume, right? Please read. V is the volume. So what is the dimension of volume? It is L cube. So it will become L to the power 6. And what is the dimension of P? So dimension of P is going to be, so dimension of P is force upon area. So force is, we remember the force now, mLT minus 2 upon L square. So what is the dimension of A? It is going to be m. Now see, L to the power 4 will be left, and it will be L to the power 5 t minus 2. Now let's see if we so directly they are asking you the dimension of A. Okay, so it is mL5 t minus 2. mL5 t minus 2. So what is your option? The option is A option. Okay, okay, okay. Easy way to do it. Otherwise, what you could have done, you could have equated the dimension of A upon V square to B upon theta by V. Now, this way also you could have solved, but for that, first of all, you have to find the dimension of B. Okay, okay. So somewhat different, somewhat tricky. Okay, somewhat tricky. Now let's move to the next question. So we have this. Okay, a big question. Let's see if we can solve it or not. So we have here what we have. So we have turpentine oil. So all these things, so they try to confuse you. So because some time is spent in reading the question also, na? And sometimes what happens, some students are getting afraid. Oh, so big question. What is there? What is not there? Don't worry about it. Very simple. Turpentine oil is flowing. Turpentine oil is flowing through. Turpentine oil is flowing through a tube of length L and radius R. Okay, very well. The pressure difference between the two ends of the tube is P. Okay, no problem. The viscosity of oil is given by eta is equal to P R square minus X square upon 4VL. So now we have V is the velocity of the oil at a distance X. of the tube. Now please understand this. So we have the dimension of eta. So what is the dimension of eta? So what is the dimension of P here? The dimension of P here is the ML minus 1 T minus 2. We just have sorted it out now in the last question. So I am using it directly, MLT minus 2. Force upon area. So L square, that is L minus 1. So I am directly using it here. Now what is the dimension of this R square minus X square? So it will be dimensionless. No, it will not be dimensionless. See, when two physical quantities are subtracted or added, their dimension do not change. Okay, so what is the dimension of L square? R square, it is L square. What is the dimension of X square? So it is L square. Okay, so what is the dimension of this difference? L square. Now we have 4 has no dimension. Okay, 4 has no dimension. So I'll write dimension of eta. Now 4 has no dimension. V is the velocity. So it is going to be LT minus 1. And L is your length again. L is your length again. Okay. Okay, so it is having the dimension of L. So from here, what we are going to get? From here, what we are going to get? So let's check. Let's check. So see, L square are getting cancelled out. So we are getting L minus 1 M. Now let's see if we have any option that has this only. Yeah. So otherwise you can do what for the T also. So obviously it is T minus 1. You can sort out the whole solution. But what I prefer and what I'm trying to tell you here, that once you reach the correct option, you just stop the question at that point. You need not to waste even a single minute after that, because you are not getting extra marks. So if you do a question correctly, you get 4 marks. You are not going to get anything more than that. Okay. So once you bottom down to the right option, you leave the question right there. Don't waste any more time. Move to the next question, as we are going to do for now. Okay. So let us move to the next question. So we have, okay, let's move to the next one. So we have this question. Let's try this one. Let's try this one. I'm quite sure we can do it. No problem at all. Please try to do. Please try to do. So what does it say? So it says, according to the Newton, the viscous force acting between the liquid layers of area A and velocity gradient delta V by delta Z is given by F is equal to minus eta A del V by del Z. So this is the formula for the which comes from what? Which comes from the Newton's law of viscosity, where eta is constant called coefficient of viscosity. The dimensional formula of this coefficient is. So again, we can move by the same way. So you have solved this in the sessions also. That's fine. So we are solving the PYQs. We are solving the previous year questions, and now we are trying to see that how questions are getting asked. Okay, we are trying to do as much as possible so that we get the idea. So according to the Newton, the viscous force acting between liquid layers of area A velocity gradient disk is given by F is equal to minus eta A del V upon del Z. Let's write the formula. So F is equal to minus of eta A del V by del Z. Okay, no worries. Okay, so what is the dimension of eta? So it is going to be, so let me write it the dimension right away. So what is the dimension of force? So it is MLT minus 2. Okay, what is the dimension to area? So it is L square, it would go down. This is delta Z. So delta Z is what? It is velocity gradient. So gradient means what? It is per unit length. Okay, so what is the dimension? The dimension is having L, that is change of length. So that is going to be the dimension of L. And what is the dimension of this velocity? It is LT minus 1. We know it very well, right? We know it very well. Do we or don't we? Do we or don't we? Yes, sir. We know it absolutely. No problem at all. Right. So now from here, what can we do? So we can sort the unit of this. So what is the unit? So L shall be cancelled out. Okay, this L. So we are getting M and this L. So it will become L minus 1 and it is becoming T minus 1. It is becoming T minus 1. So we are getting M L minus 1 T minus 1. So that is going to be the D option. That is going to be the D option. Okay. So, like also students, what happens with time when you read these chapters lately? Okay, so when you move ahead in your journey of the physics, you are going to see the properties of fluid, you are going to see the properties of solid. So when you are coming up to those chapters, what is going to happen? You are going to see the formula of dynamic viscosity very frequently. In many questions, you are going to see the coefficient of dynamic viscosity. So sometimes what happens that you remember the units, their units right away. Okay. So from units also you can come up with the dimension, right? From units also you can come up with the dimension. So here we have some more questions, and I am very sure you can solve them like this. Okay. Okay. So what is the dimension formula of pressure? So we already have done it. The dimension formula of pressure is ml minus 1 t minus 2. What is the dimensional formula of torque? So for dimensional formula of torque, so F into distance. So force into distance, Newton meter. So we are getting ml squared t minus 2. So just by thinking in your mind, just having some thoughts in your mind, you can answer them very, very clearly. Okay, very, very clearly. Okay. Now, similarly, we have one more simple question. I'll make it here only. Very, very simple. Very, very simple. So, the dimensional formula for angular momentum. The dimensional formula for angular momentum. Sir, what is it? What is the dimensional formula of angular momentum? What is the dimensional formula of angular momentum? So the dimensional formula of angular momentum is, so we know angular momentum is I omega, so it is going to be ml squared t minus 1. So that is going to be the B option. That is going to be what? That is going to be your B option. Okay. Okay. So similarly, guys, we can do many questions. So there is no end of doing the questions anyway. Okay, there is no end to it. There is no end to all this, right? Okay, so all you can do. So in this session, how many questions we have solved? Let's see. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So guys, in this session we have solved 16 PYQs, 16 previous year NEET questions. Okay, and from this session you must get understanding of that how the questions are getting asked in the NEET examination from this particular section of this chapter, that is the units and measurement. Okay, so guys, I am hoping that you have enjoyed this session, you have learned from it. Okay. Okay, and keep practicing the questions. See, there are a lot more previous year questions. I also see nobody can do all the PYQs in these sessions. I'm trying to give you the idea that how previous year questions are getting asked. Okay. Okay, so I hope you guys have enjoyed this video. You guys have found this video interesting. You guys found this video informative and useful for your preparation. So guys, one last thing for the day, please don't forget to subscribe the channel, your only channel, Need Success Simplified. So we are here to serve you, we are here to help you. Okay. Okay, so please follow the channel, please subscribe, please share, please like the video. And with this, thank you very much. I'm going to see you in the next session. I'm going to come up with few more previous year questions from the part of error analysis and significant figures. Okay, so see you in the next session. Have a good day.